Hello! For this video, we are going to talk about the limit of a complex function. Yes, there are also limits for complex numbers, specifically for complex function. They actually just follow the same definition as for the limits of real numbers. But of course, since we're talking about complex numbers, you're going to introduce the representation for z and its equivalent value. So let me write here some definition or its definition, and then later on provide you with some examples. For the definition for the limit of a complex function, we can actually write in this manner: let f of z, okay, be a complex function, meaning it's a function of complex numbers, and let's say z sub 0, okay, be a point in the complex plane. Okay. Then just like the definition for a limit of real number, we can say here, we can say that a certain limit, okay, the limit of your function f of z as your z approaches your z sub 0 must be equal to L, just any representation, if for every epsilon greater than 0, okay, no matter how small it is, there exists a delta greater than 0 as well, such that, okay, if you have here the absolute value of your z minus z sub 0 be greater than 0 but less than delta, then your f of z minus your L must be less than your epsilon. This is only true if this idea here or conditions will be met. And that certain L is your limit of your complex function. Okay? So basically, it is structured the same way as the definition for the limit of real numbers. It's just that at this time, we are considering f of z being a complex function. In short, all of the possible values for z are complex. So here are some notations or conditions you need to remind yourselves with. Okay, just notes here, very important to be guided. So this would be different from the limit or definition of limit for real numbers. We have here, the first note is your z and your z sub 0 are complex numbers. Okay? That would mean your z for your function of z is a complex number. That would mean it could be a real number or a combination of real number and an imaginary part together with your z sub 0 as well. That would mean you can represent here your z as the notation for your complex number. You can write it as x plus iy, and of course your z sub 0 can also be written as x sub 0 plus I y sub 0 or y sub 0 I. Okay? The second note here is your, of course, your L is a complex number as well. So whatever be its representation, it could also be written in this value here. Okay, L, we know that L is the limit. And very important to be guided, the notation of the absolute value of z minus z sub 0 is the distance. Okay, don't forget that it's a distance between your z and z sub 0 in the complex plane. Okay? So if we talk about the complex plane or the Argand plane, we might be introducing here certain theta or angles as mentioned in the previous video. So again, the notation or the definition looks similar to the limit of real numbers or functions with real numbers. But this time, since we're talking about the complex function, then we are going to use here the values for z, and it should represent in this manner. The next few items later on would include some limit theorems for complex number and some representation or examples of solving the limit of a complex function using this definition or some evaluation as well. Thank you very much for watching.